Good morning, everybody. Finally, I'm very happy to see you, and I'm happy to see the people that I can't see because they're at home and watching. And I'll be happy if you see that later on because I've recorded and published that. Even then, I'll be happy. Today is the third lesson, or today we'll do the third lesson of CAET1, which is also the third lesson of CREO modeling strategies. And today we'll mostly deal with assemblies and features that will support a proper top-down strategy when modeling with CAD. So in order to start with, I would like to give you an overview of realistic design processes, especially when you are developing consumer goods. There is a very early need to show finished, or not finished, but to show something on screen. Later on in this semester, we will discuss the general process of design engineering. And in that process, we will learn that actually we start with CAD later in the process, that we first do concept development and so on. And so there seem to be a few approaches that seem to be contradicting each other, right? So first, generally, we have the idea that we want to develop a concept first and start with CAD pretty late, right? Then there's the concept of top-down, bottom-up development or engineering. Are you aware of that term, top-down, bottom-up? Did you ever hear about top-down, bottom-up? So that's the general strategy of first looking at the overall system, right? Always the overall system, and then breaking that down into its elements, and then realizing the elements and putting the elements back together again, like the parts. Now with CAD design, how do you usually work with 3D? Normally you feel you have to make part models first, right? And then put the part models into one assembly. That would be bottom up, right? But later on we'll discuss that more. Generally, it's a good idea to think in a top-down strategy. So keep the overall product in mind, the overall function, right? So top-down, break it down, then bottom up. But now we learn CAD, you think we can only work bottom up, which means make parts, put the parts together. So that is a conflict, right? So the question is, can we work with CAD? Can we work in a top-down, bottom-up way? How is that possible? So if we look at that process, basically what it says, step 2 already, we have a 3D CAD model, right? So first, phase 1 would be to develop a concept, decide on technologies that we want to use maybe for the production. And then very early on, we already have a 3D CAD model. We might already make a prototype. And then actually we go into iteration, which means we make changes after we tried it. So generally, there is a need to have a CAD model very early on. And that actually coincides, that actually supports the general idea that working top-down first is a good approach. So how do we do that? How can we have an assembly of a product in CAD when we don't have the parts? Is that possible? Can we have an assembly model of, so we have people shaking their head here, and actually today we will learn, yes, it is possible. We can have an assembly in CAD before the parts are at least finished, right? And this is very useful strategy. That would be a top-down strategy in CAD because it allows us to actually try some things out in the assembly. For example, if we have moving parts, we can already check if the parts can move, if there's, for example, enough space for parts to move, if the overall concept is working. So today we'll try to learn this. How can we start with an assembly very early on in the CAD design when we don't have the finished parts? And then when we have an assembly early on, we can then work on the components later on and keep on detailing them, but they're already in the assembly. So we can always switch between the parts, which we're detailing in the assembly view, where we can check how the design is working. If you don't know this approach that we will learn today, if you learn like most people would, if you work like most people would do, which is bottom up, then you will have a lot of disappointments, right? You will work on individual parts first, maybe spend many hours on making the parts. Then you put the parts together in an assembly, and it will not really work, right? Maybe parts will collide when they should be moving, right? This is always very frustrating, and then you often have to go back, and it's actually more work. So the reason why we're looking at this top-down, bottom-up strategy in CAD is mainly because it will save you time in the long run, right? It will allow you to check the feasibility of your design very early on, and it will, in the long run, save you a lot of modeling time because you don't have to repair so much, because there's not so many disappointments, not so many errors going on. Okay. Now the question is, how can we make an assembly if the components are not finished yet? And the answer is the last point on this slide. Basically, by the use of skeleton models, right? Now the question is, what is a skeleton model? Here's one example of where I used this strategy a long time ago, very early on, and that was basically developing a complex part for serial production, or rather a complex product with many parts and a pretty complex movement. So very early on, it was an important requirement in this design that the backrest can go back very far, 29 degrees. And if you think about it, that means that we have space problems, because if the backrest goes back a lot, then that will collide with other parts that are there already. So you have to design the backrest so it basically leaves enough space for that movement. And you see highlighted here in red, this is the rear part of the housing that is connected with the backrest. And you can already see that basically it has this arm here, which goes around everything. And this is to allow for this movement, right? So, so you want to be sure you have a working concept before you put all the many hours into designing these parts. And again, this was made possible by the use of a skeleton model. Basically, the first part in this assembly is only a sketch. It's called ref here for reference part, but I could have called it skeleton part. So you can't see it on the screen here, but basically that first part is a sketch of the mechanism, which only contains the main points and axes and datum planes. And I can change the sketch to show the movement of the mechanism, but all the parts that are put into the assembly are referencing that first sketch. So if I change the sketch, the position of all the parts will change, even if the parts are not fully modeled. So that is a pretty complicated example. So I will show you a simple example that you can understand first. That would be the use of a skeleton model for a mechanism that would be a basic rocker mechanism that has 3 moving parts. So at the moment, normally I would now go to the whiteboard and make the sketch. So you can see the green lines here. These represent a sketch, and actually what the sketch represents is a mechanism where this first line is a linkage that can rotate around the bottom axis. Where's my mouse? So this bottom axis will be fixed in space, maybe connected to a housing. That rocker here, where's my mouse again? That rocker here can rotate around it, right? And the same to the third line. The third line is also pivoting around this axis, so it can rotate around. But these two parts, the first line and the last line, they are connected by a third, which is like a linkage basically. So if one of the, if we actually rotate the first or the third part, it will drive the other parts, and the linkage will make some sort of rocking movement, something like that. So this is a good example for this technique of top-down working, because I will basically make a CAD model that will not represent a real part, but basically the mechanism structure. So I could call this mechanism skeleton, like I did here, and it only contains the sketch. And in the sketch, I can actually put axes on the points of the sketch. And then this part, for example, I can put into the assembly as, and I can fully constrain it because I can reference the skeleton model. So let's look at the sketch. This is an extra part model, part called skeleton or whatever, mechanism sketch. And I can make the sketch inside. And you see here that the two red points are the end points of the mechanism, the non-moving parts of the mechanism. And then I have 3 lines in here, and I can define the lengths of the lines, which will be the distance of the 2 holes in these parts. And I can lock the these dimensions. This is why they're red, because they're locked. And the only free dimension in this sketch is the angle. And this is how I can simulate the rotation of the first part. So in the real mechanism, this line will be connected maybe to a motor who will make it go round, and then the other parts will follow it. So this is my example of a sketch in a skeleton model. And then I can put axes on these points, and I can use these axes in the assembly to reference parts to that. So I suggest maybe I'll just quickly go through that example first, and then we have an overview of the complete process, and that is the main part of today's lesson. Okay, so let's do that first. I just try to remember the dimensions. So we have a distance of 40 to the 2 fixed points, and then the lengths are, I start counting here because this will be the drive, 20, 40, 30. So let's go to this. What is the first step in CREO? Select the working directory, indeed, right? So I should still have my working directory on the desktop, right? And now the first thing I will do is, in this case, to make a part model, but I will call it skeleton. I'm never quite sure how to spell skeleton, but there you go. So, and what I will do here is I will make a sketch, right? That is not a contradiction to what I said before. I will make the sketch in the right plane. I want the top plane to be on the top. And I will now just sketch the 3 lines of the mechanism. And now I will define dimensions. I said this one has a length of 40, I believe, right? This one will have a length of, oh no, this one was 40, right? This one was only 30, right? This one was only 30, right? The last one has a length of 20. See, and this is a good example. Now there's this complaint of CREO, and it says, well, these dimensions are contradicting, and this is, I think, because I just lost overview here a bit. I actually dimensioned that already. Hang on. So this one should be 20. This one, I believe, was 30. And the distance of these 2 points was 40, I believe. The length of this is 20. And it will not allow me to make that change because CREO is is having its own mind again, right? So sometimes it helps if you can't regenerate a different dimension value, just drag the points a bit, right? So again, I'll try again. So this one should be 20. And now the sketch is not fully constrained yet. There's still 1 degree of freedom left. And I want to define this by this angle. And then the other light blue dimension that was here before disappears. So, again, so this. So now, as I said, I want to lock the lengths of these lines, which will represent mechanism linkages. So if I change the sketch to show a different position, it showed they will not change. And you'll see this little sign here that obviously is a lock. If I right-hand click the dimension, so mark first, right-hand click. This one too. So now I can change this and it will look like the mechanism is moving. So one button that I haven't shown you yet is the dynamic change, but I wonder, actually you have the better version of this menu here. Modify, it's called modify. So you just select this dimension, then you have this wheel. And look, it is, now the problem is I can't go higher than or lower than 0, right? But I can go more than 180. So it's, actually I changed the sensitivity so I don't have to move it so much. See, this is a cool function, this modify, if you have to gradually change dimension. And you see, this is working like the mechanism. This is basically a principal sketch of the mechanism that I want to design. So obviously it cannot go more than 360 degrees. Or maybe it can. Wow, it can. Now that's new. In the older version, it wouldn't support me. But now you can actually make it go all the way around. Great. Okay, so you can tell that I can easily simulate all positions of that mechanism like that. I just keep it in any random position. And what I will do now is create the assembly and just call that mechanism. It should be an assembly file. I create that and I can already assemble this first skeleton model in there. Now you've not used assembly before. Actually, there's not so many functions in assembly that you need. The main problem is to reference different parts properly. So you will enter a new part by this button, assembly, obviously. And I can't see my skeleton model here. This is because I haven't saved it yet. So it's not not on the hard disk drive yet, right? However, so I could now go back and save it, and then it would be in this list. However, there's also the other thing you can do is you can look in the working directory, in the working memory of your computer. So if you go to the left, click on in session, that will show you all the parts that are in the memory already, which in this case, the part skeleton is in its memory, but I haven't saved it yet, but I can already put it in the assembly. With most parts, when you assemble them, you will typically constrain 3 degrees of freedom, like 3 definitions. The first part, I could also do 3 degrees of freedom. I could align 3 pairs of planes, but I can be a bit lazy with the first one. I can actually take the standard default constraint. That is one constraint. It will fix it in space completely. Basically, this is the same as aligning the 2 front planes, the 2 right planes, and the 2 top planes. That is pretty handy because now with only one click, this is fully constrained. Okay. So the next thing that I already did is I will make a rough model of the linkage that I want to put in the middle, right? So normally, if you try to assemble this in a bottom-up way, you would first make the 3 linkage paths, and then you would think, huh, how can I put them together in the assembly, right? you would probably put the first one in that starts on the housing and then try to connect the second one to the first one, right? But this will not be satisfying. That will not be easy. At least there are ways how to do that, but this is basically the easy way. So you can already have a rough assembly of this one, or sorry, a rough component. So I'll make a new part again. I call that linkage. And basically, I don't have to do anything, but actually, it makes sense to already have a rough geometry here. So I will use extrude. Again, it always puts the front. It always aligns it like that, which doesn't make sense. Why should top be on the left? That doesn't make sense. Put top on the top, right? Okay, that always annoys me quite a lot. So I will make a rough linkage here with 2 holes. Bam. Distance of the holes is 40, right? That was 40. I always forget stuff. And maybe these holes can have a 5 diameter. And I can just, no, not this one. What happens? So this is very ugly, but I'm just showing you this is not my finished design. So I don't care. It's ugly. I can finish it later. And that's the whole idea. I can finish it later, put it in the assembly first. Maybe that's 10 millimeters wide. I use the symmetric no, I don't want to cancel. What did I click? I wanted to click this one. Okay, I can save it. Because now you can, if you now go into the mechanism and you want to assemble this part, it is actually already in this list. I don't have to look in session. So what I can do now is, now I show you a standard placement. I can, of course, first maybe make the center plane coincident with that one, right? And now 2 more constraints. Tell me what would be the 2 other constraints? Well, I want to make sure that the holes of that linkage coincide with the points of that mechanism, right? And you will have a hard time. Actually, it is possible. I could say, well, I have axes here. I can show the axes. Let's switch off the planes. So I have axes in the holes. And it is possible to align them with these points. But actually, I think it would be nicer to have axes on the skeleton model, right? So what I will do is I will not finish the constraints. I will click OK. Now what you see here is you see a little white square here in the model tree. That is a symbol. It means it's not fully constrained yet. Okay, so it's in there, but its position is not fully defined. I will now go back to this one, to the skeleton model, to actually put axes in there. Where's the open? I just changed the window like that. Skeleton here. So this is also for me a good opportunity to show you how to model datums, right? I think you haven't done that yet because there were always enough datums. Now an axis is a datum, right? So these planes are also datums. So you can click this button here, the brown button that says axis, and now you just tell it where the axis should be. Now I want the axis to go through this point. So I click on the point, and it says, yeah, I can put the axis through the point. And the next constraint I want to have is I want to make this normal to this plane. So it should have a right angle. It should pierce it. And so I hold the control button down to click on the second reference, right? If I don't hold the control button down, it will just kill the first one, select the second one. So with the control button down, I have 2 items here in the list, and it already assumes the right thing. It assumes that I want to have the axis normal to this right datum plane. So now I can click OK, and I have an axis. It's here in the model tree. Very useful. I'll do the same thing again. Click axis, click the point first, hold control button down, click on this plane. The assumptions here is through the point and normal to the plane, which is great. So now I have two axes. I can now save that. And by the way, I always use the middle button to say enter, right? This is why I don't click the OK in the menu, because I'm too lazy. I just click middle mouse and it's fine. So I go back into the assembly mechanism. And now I can finish constraining this part. I just switched on the edges, and I can actually switch off the planes. I don't need them now. So this would be a redefinition. This is this very important symbol here, edit definition. So I've showed it to you before. This you can use if you need to make big changes in any feature, even if you're modeling a component and you have to change the sketch. Not only change the dimension value, but really change the sketch. This is the button that you use. So in this case, I'm changing the constraints, the assembly constraints, edit definition. I will get the same menu. I can change everything. So you see here, it only says partially constrained. That's not fully constrained. And now I can add a new constraint. I want something to be coincident. And these are the axes. So there's an axis in the hole. I want this to be coincident with this one. That worked, but I need one more constraint. Again, coincidence, and again, this time it's this axis in this hole. I will click on this axis and this. So here, when I choose the constraints between assembly, so this one of the two fields will be the assembly datum, or reference rather, component reference, and this one you see is the part reference. I don't have to hold the control button down. So I just click on one, click on the other. Okay. So now, if I finish this, you see that this little rectangle is not there anymore. And this is because now it's fully constrained. So I can have an assembly. It's not very exciting assembly. There's not a lot of stuff in there, but I can already make changes. For example, I can change the value in the sketch. So actually, I can go back to the sketch, skeleton, and change it here. Let's do that. Just double click that, change that value to be, I don't know, 10 degrees. So now it's completely different. Regenerate, this button, very important, regenerate. And let's see what happens in the assembly, which is called mechanism. It seems not only the sketch changed, but that's normal. I just need to regenerate the assembly. Again, this button, regenerate. Okay, so it works. By the way, of course, probably if you have some experience in CAD, you want to define a mechanism anyway, where maybe it can run around automatically. CREO can do that, but we don't do that today. Today we just want to know how we can start with an assembly model very early on by using a skeleton model. So let's do that first. That will be your first interactive little exercise. Follow that example. I will share this sketch with you, so you have a working sketch of that mechanism. So again, you have one component called skeleton. The only thing in that skeleton is the sketch and the two axes going through the 2 points. You then start a new assembly file. You assemble that skeleton in there as the first component. And then you can basically make rough component models for all the actual parts. Now, I only did one, which is the linkage part of the middle member, and then put that into the assembly and show how you can change that position. That will be your first exercise. I'll give you, let's say, 15 minutes to that, and see you in about 15 minutes. Bye-bye. So I'll pause this recording if it lets me do that. Again, the button is different every time. How can this menu be different every time? Pause recording. So let's continue. As I did before, I will first go into the presentation and show you the next
next example that we'll be working on. And then I'll give you some time to try to do it yourself. So now the focus is on patterns, right? I think all of you know patterns already from your previous CAD experience, and I sometimes hear people complain about patterns in CREO, but it's quite a useful thing, especially for assemblies again, because often you have assemblies where you have some features repeated many times, like screws, right? So this example that we look at now, don't try to understand what it's good for. It's a stupid little example that I came up with last year. So this is maybe one plate, and then we have some sort of sink, right? And the sink is bolted onto the plate with many screws, right? So normally when you make the assembly and you would have to assemble each screw separately, you would go crazy, right? You would lose your mind pretty easily. So what I want to show you now is if you properly model the feature, then it is very easy in the assembly to put in a large number of repeating items like screws. So so in this little bit, I will show you how to model patterns, but I will also show you where you can get standard parts on the internet for free, or models of standard parts, trace parts online, right? So that is side knowledge. But I'll start with modeling these two parts. And actually, I will probably be double super lazy, because you know I'm a very lazy person, right? So I will actually start modeling one part and then copy that part and change the copy. So I will make the plate first. This is, maybe it's not clear here because it's the same color. So that lower part, that would be the plate. I will model that first with a pattern of holes. Then I will just save a copy of that, and I make this sink from the copy. So let's go to CREO. I will make a new part. I don't have a good name for that now, so I'll just call it plate. It's not a terribly good name. So I will just make an extruded shape here. It will be symmetrical. I haven't yet figured out how to change the menu again. So that's going to be pretty large, maybe 1000 by 600. I don't know yet. So I'm improvising here. 1, 2, 3. So that will be the plate, 1000 by 600, and I'll make that maybe 50 thick. No big deal, that was easy. So now I have to do some calculations about a good pattern for screws, maybe 20 millimeter distance, or let's say 50, we don't want to have too many. So I'll make a first hole. I'll do that by using one hole. So the beginning of a pattern is one feature, and what is important, most patterns you pattern by dimension. And so you model the original feature, and it is important that the dimensions that control this first feature can be used for defining the pattern. Okay, so I will put a hole here where my mouse is now, and I will put in one dimension to define the position with respect to this surface, and a second dimension to give the distance to that surface. And then I can use the first dimension to pattern it in this direction, and I can use the second dimension to pattern it in this direction. This is, the word direction is also used in the pattern function, right, in the pattern feature. So again, I'm just put in the hole here. That's a bit big. Let's say maybe I need 12 millimeters, maybe for an M10 screw, something like that. You remember the whole feature. I open this tab with the menus. I click into the offset references, and then I with the control button down, I give the two offset references, and I'll just give this distance. So maybe 25. I haven't checked the math yet. I'm not yet sure if my pattern will look good. But that's all I need. The only other thing, of course, define the depth through all. So this is one hole. And with this one hole, I can create a pattern. So if you highlight this, or no, let's go the other way around. So now there's nothing highlighted. You see the pattern button up here, and it's not, you can't use it, right? I click on it, nothing happens. So in order for it to become active, you need to highlight a feature that can be patterned, okay? Now you can click on the pattern button. The other way to do it is just right-hand click it, and it will also offer you to do a pattern, right? Same thing. Okay, so as you see, nothing happened yet. You have to define the type of pattern. So again, I always like to go into the first menu. And if you give it dimensions that define the direction of the pattern, then it knows what you want to do. So you see you have two windows here, direction 1, direction 2. So direction 1, I define by choosing the dimension that gives me the direction. And then you can see it wants me to change the value. This will be the distance between the patterned items. So I put 50 in for 50 millimeters here. So now you see two dots. And that means at the moment, it is trying to create only 2 copies. And this is this little one up here. So actually, I haven't done the math. That's a bit embarrassing here. Maybe 12. 12 was good. Good guess. Wow, I like it. So so that would be 12 items here in direction 1. But I actually want it to go in 2 directions. So I click into the second menu, and then I can select this. And again, it will be 50. And again, I have to define how many features. No, how many could that be? 22 maybe? Just guessing. No, that was too much. Just 20. 20. Is that? I'm not sure about the edge. Oh, the edges look good. So we have nice equal distance. That looks good. So actually, this is not what we want, right? We want the holes only on the outside. So what we could do is just pattern only one line and then copy the line, and then the best way is this way, right? Now what you have to do is you have to deselect the ones you don't want to have. Now with this pattern, that's quite a lot of clicking. But at the moment, I don't have a better solution. So you see what I'm doing? I'm sure there's a better solution for that, but at the moment, I don't know it. So that's a bit stupid maybe, but let's just assume this is the only way to do it. If you find out if there's a better way to deselect all these, you can tell me. I might be the teacher, but I'm very happy to learn every day. So there you go. That's terrible, you know. I'm a bit too lazy to do that. So you know what I'll do? I'll just change the number. Just change the number of items. And I'll change the spacing to be 100 because I'm lazy, you know that. Increment high. Why can't I change the increment? Will you please just let me change the number? So that's okay. Then now the one thing I have to change is the initial dimension, no problem. I'm just finishing that now. And if you want to change the dimension of the first item, you have to open the pattern, and the first one is the original, right? So here I can just change this initial dimension. Yeah, now that looks better. Regenerate, bam. And I can, and now if I want to hide some of these features, you just go to redefine. Look, edit definition, and then again, actually, I want to have these back, so you can have them back. That is the good thing. Now watch me doing silly clicks many times. It's like, to make it more exciting, you can go like you're playing Pac-Man. Oh no, dead end road. Okay, soon done. I missed that one. Fine, finally we have, great, we missed, I missed one. This one, bam. Okay, so the good thing is you can get these things back, right? Sip of coffee. So I will also now, because I'm lazy, create the other part just by copying this one. So I do save as, save a copy, and I call this sync. Now be careful, the window that is open is still the old one. Sync is not yet open. That's different than in all other programs, you know, right? So to open sync, you have to go open, sync. Dangerous. So what I will do now is I will use the shell function to make the sync. Maybe you might have wondered how I make the sync. So what I do first is I make this a lot thicker. Where's my dimension? Where's my dimension? Can't see it. Ah, there. So good kitchen sink, maybe 400. Regenerate. And what I will do is I will cut out the inside of the sink. And then I will turn this solid block into a shell. And I want to have a pattern at the last, as the last feature, after I make the sink, right? So that means I want to put in my features before the pattern. So this is why I grab this little green arrow and I move it up, insert here. So now I can put new features in, and the old features will come later. So again, what I do first is I will cut this out. No, sorry, I misclicked. This is not what I wanted to do. I wanted to click here. Yes. So you can change anything that can go wrong. No, this didn't work though. What did I do? I don't want to. Will you stop changing my decisions? This is where I want to sketch. Great. I can again use this box, although I don't really like the box. What I like is use symmetries, but the box is easy for now. This was 600. The hole was under 50, 100, 100. So that will be 400, something like that. That's on the fly design. This is 1000 minus 200 should be 800. Cut out any length that is shorter than the material of the thickness material. Actually, I will show you something new, something you don't know yet. Is I can actually, sorry, I have to redefine it. I can actually make this tapered. Just as a side information here under options, you can add a tapper because the side of the sink are not straight, they go in a bit, right? There are other ways to do that, but today I'll just show you this one. 5 degrees, yay, okay, nice. Also, a sink must have nice rounds, of course. So I think we haven't tried the round feature yet. So I'll explain the round feature to you now. Now, what is important is that in the round feature, you can have multiple sets, right? But if you have many rounds with the same radius, you want to have them in one set, one group. That means in my first set, to select all the edges, I keep the control button down. Okay, so these four will be my set one, and I will give them a nice big radius, maybe 50. Looks like a good old-fashioned sink. And now I can make a second set if I want to. The problem is if you don't hold the control button down, it works, but you can select many edges, but they will make a new set for every edge. And then you have to change the radius for every edge. You don't want to do that, right? So now I will round the bottom. And the problem with that is, oh, it's no big problem. I'll just change the radius, make a smaller radius, because I want it to go round on the bottom. Now, see, it doesn't do that. So if I finish that, look, it only makes one round. If you've modeled before, you know what I want to do, right? I want the bottom round to go around automatically. This doesn't work if I do it as set 2. So I have to make it as a new round after the first round. So I redefine that first round and I just delete set 2 because it doesn't work like that. Now I make a new round. Just click only one. See, now it connects all these. That's maybe a bit bigger, maybe 40. It doesn't matter though. So here's my sink. Now comes the magic trick. This is like a concrete sink, but I want to have a sheet metal sink. And we have this cool function called shell. So maybe that's 2 millimeter steel. Now you don't see anything yet, because what you have to define, the surfaces that are not there anymore, removed. So just click on the bottom first, then you understand what it does. With the control button, I will also take the side surfaces out. Cool, right? So now I'm hoping that the pattern, if I reactivate it, still understands the original references. And yay, I did it again. Beautiful. Okay. So now, actually, there's one thing I could improve. So I'll show you, number one, I'll show you how, if you design it like that, it has a big advantage if you make the assembly. Because both parts have the same location in space. I can put them into an assembly using default, right? But in this case, I should have had the plate model up and the sink model down. Now, if I then put them into the assembly, both with default, they already have a perfect placement. Okay, so this is something I have to repair, but that should be easy enough. So I'll make an assembly, I'll call it sink, and I will put in the plate first, but the plate is not there because I haven't saved it, right? I have to look in session. It's still new, and I have to remember, please save it later, right? Where's the plate? I call it plate, right? Ah, here it is. And lazy guy, you can choose that here, you can choose default. Then the lazy guy takes the sink, also default. Yeah, that's pretty good, but not perfect. I want the plate and the sink on top of each other. I remember they're both the same part. The first feature went down. So I just open the plate again and I redefine the first feature to go up. And then they should meet in that plane. But actually it's fully placed. I just open up plate again and I go into the first feature, edit definitions, and the only thing I edit is the direction. Okay? And I'm just checking, oh, lucky that there's no confusion about the holes, right? Maybe now the holes go in the wrong direction, but I actually chose the material surface, so everything is fine. While I'm here, it would be a good idea to save it now, right? So I go back into the assembly. and just to make sure I can regenerate it. And look at this. Now the two parts are on top of each other. And I did the laziest placement of all time. Okay? Now the only thing I need now is a lot of screws. And of course, you don't want to model screws, right? Because you're also lazy, right? Like me. I'm teaching you to be lazy. So how can you get screws? Now, many years ago, the industry thought they could make a lot of money by selling databases with standard parts. And some companies actually modeled their own databases with standard parts. When I was still a student in around the year 1996 or 1997, I still had to do one internship, and I went to the very big company Procter & Gamble. Maybe you know them. They make a lot of shampoo, toothpaste. Very big American company. And if you go into 7-Eleven, I would say 20% of the stuff they're selling is from Procter & Gamble, right? Anyhow, so I did internship there in the design department in Euskirchen in Germany. Not product design, but they design the machines that make the product, like automatic packing of Pampers and stuff. And they just started using 3D CAD, and they had SolidWorks at the time. And my first job in this internship was to automatically create database of standard parts. So I made a model of a screw, and I modeled it so it could read the dimension values out of an Excel. So step one, they call that a mother part. Then get the book that gives me all the dimensions of all the sizes of screws and copy these dimensions into an Excel sheet. And then make SolidWorks, open the Excel sheet and automatically make a new version of the part with the new dimensions from the Excel sheet, every size, M2, M4, M5, M6. And save that new file with a new name. So that was an industry that there was quite some companies that said, oh, we can make money. We make a database of standard parts and sell on a CD-ROM to the companies. But the problem is soon after that, this stuff was available free on the internet. And actually, because now they realize, actually, if I give you free CAD model of my parts, maybe you come and buy my parts. So this is a new style of Kosana, new style of advertisement. So for example, let's say I have a factory, I make screws. Now what I do is I just give my CAD model for free. And then everybody who uses my free CAD models, maybe they remember my name and buy my real screws. Now the internet is a great thing. Somebody else had the even better idea. They made a website where everybody who wants to sell stuff and give free CAD models, they just give the free CAD model to the website. And now it's a big online catalog. You can get everything there. Do you know the website that I'm talking about already? It's called Trace Parts, traceparts.com. So let's see. So this would be something you do now. So I use it quite a lot, traceparts.com. I suggest you register there. You can do that now. And after that, you can always download all your stuff, screws, balls, but also more complicated stuff, bearings, and even pedestal bearings. Basically, you can almost, it seems you can find everything there that you can buy as mechanical engineering components. So before you do that, I will show you the whole value chain, so to speak. So I'll check what parts I need. So I think I made 12mm holes. So I think I need M10 screws. So I will just measure a bit. So for measuring, you go to the analysis tab, and I want to know how long my screw needs to be. So I check the distance from here to there, 52. Right, so I want M10, and it has to be longer than 52 because I want to put a nut on it. So I guess maybe 60 should be fine, right? So I'm looking for a screw M10 by 60. I will use one with a hexagon head, M10 by 60, and I need a nut. So let's go shopping. Now, in real life, of course, I have to buy a lot of screws. Here, I just get one and copy it myself. So I could search for screw, but actually that is a bit tedious. So you can see this website, you don't have to pay anything there, right? But obviously the companies that put their models on this website, they have to pay that because they basically, this is advertisement that they're selling, but they selling it for free. Well, the people who want to sell stuff have to pay, but we want to have free models. We don't have to pay anything. So this is really a great website. It's really old already. It's this, I don't know, this was invented like 15 years ago or so. And the people who, all the designers get it for free. So here are, if you scroll down, you find the different categories, and you go to mechanical components, I believe, and then you find fasteners. So that this website is always changing. You see all the Cosana, all the advertisements here, right? This is how it works. But I don't care. I like pictures of screws. So you go on, actually I like this. I prefer fasteners. You go screws and balls. You want Hags head balls. It's funny, that's a category of its own. Actually, it should be, I go back, that's not what I want. Maybe it's just on the cap screw. Hexagonal screws, yay. And then I just choose, now you see, this is where they start fighting, right? So obviously you have, these are all the same screws because they're standardized, right? But you have different companies. So now you think, which model should I take? Doesn't really matter, right? But I have to say, and I have no formal association with this company, right? They don't pay me. But I always seem to download Norelem. I think it's a French producer. And I have to admit, I've never ever bought a screw of theirs. Not that I know of. And then normally down here, you can choose the size. And of course, there are a lot of sizes. So I just try to find M10. What? No? Page 5. What is going on? Oh, M12, sorry. Page 4 is M10, great. And what did I say, 60? Did I say 60? Okay, so what I do is I click on that one to mark it. And then you choose the format. And actually, you can, I think you're safe if you choose a generic format, one format that is an exchange format. So for example, IGES is not bad. You can do IGES. They also have CREO, and I think it works both on commercial and non-commercial. So you can choose CREO. But what I don't like about the specific files is that they often have version conflicts. So I'd rather download IGES. What I also read, what is a good standard for mechanical engineering is STEP. So STEP or IGES, actually STEP is even more reliable if I can find it. Of course, they're way more. Oh no, they have different versions of STEP. I'll just try this one, AP203. Oh, I don't know what that is. You know what? You can try that. VDA works great too. VDA is automotive industry standard. JT is also a standard you can use, but I just use the good old IGES. Now I download the file, and I think it doesn't directly download it. And then this is where you either have to register or sign in. And I'm of course registered. I'm a frequent customer because I need a lot of screws. So I think it's not downloaded yet, but it's put into some sort of shopping cart. Maybe I just better click that again. See, I can't see my shopping cart because the camera is here. So something is happening. So up here, this would be like the shopping cart if you did real online shopping. And it's, I think the server in the background is now generating my file and we'll put it here. And when I'm ready to check out, I just, see, something is happening now. One popped up, so there's one part. Now actually, I still need the nut, M10. So I actually don't know, should I just go back or is there a link? I think I just go back. I don't think it will, well, we'll see. Maybe I just forgot my shopping cart. Mechanical components, fasteners, nuts. Hexagon nuts, here we are, hex nuts. So of course they're all the same. D934 is standard, or ISO 4032. So it's all the same. I don't even know why Norelem has two categories, because this should be the same. Of course there are thin nuts too, but I don't want thin nuts. I forgot something at home. Just got a warning from my wife. Ay, ay, ay. So M10, just choose this one, no big deal. And then again, download. And see, this is the modern cookie technology. Now it says 2 up here, you see, on my screen. And now for some reason it says save file, which it didn't do before. I'm wondering, what have I saved now? I think it's only one file. Let's go there. Let's click on that. Yeah, see, this video thing is always getting. I'm not sure if I downloaded them already, but here from your card, you can really download that. Just to make sure I have it all. Download. So we're not done yet. There's still a lot more I have to teach you. Oh no, maybe let's take a break here, otherwise you forget about it. Take a little break and you model the sink and the pool and download the screws. And then I will show you after the break how to, what is the laziest way to put all the screws into your assembly. Okay, so let's take a break here. I am pausing the recording. Well, yeah, sorry about that. I forgot to record the last bit. Well, anyway, I'll do a quick recap of what I did. You can do it. I'll keep on talking. So as you see now, I have the assembly with all the screws and nuts in there already. I will just delete that, just to try to do it again for your convenience. So actually, I will delete the whole thing and this thing. So what I talked about before was importing the IGES files. So the first thing you should do is take the zip files that you downloaded and copy or paste them rather into your working directory, and then of course unzip them, and then there will be an IGES file in this case, and also a text file. And I've deleted the text files; they're not necessary. Now the IGES files you don't want to put into the assembly directly, so I suggest you import the IGES files. In order to do so, you need to go on all files. So you say open file, and here under type you'd select all files, and then you can see the IGES files. Okay, so you would import them. Then you can choose what kind of file they should be transformed into. In this case, it's a part file, and you might also choose a meaningful name here for that file. For example, hex screw M10X60, I think it was. Okay, so then when you import it, and if you hit save now, it will save it as a CREO file. However, I also suggested before you do that, you should have proper datums in there that you need for placing them in the assembly. And with a part like a screw, the most important datum would be an axis. So you click up here in the submenu datum and axis, and the only reference you need for an axis is this cylinder. So you click OK. Now you see in the model tree you have an axis. You can save the file. Okay. Now let's place this in the assembly. And again, what we want to do is we want to save work, right? Now, if you don't know the functionality and if you don't plan properly, you would have to place one screw in each of these holes. And this is nerve-wracking, right? You don't want to do that. Also, if you change the screw, you would have to change everything. So instead, what you can do is you reference the pattern of the holes. Then you only have to put in the screw one time, and then you can apply a pattern, and it will use the original pattern, so you don't have to do anything else. But in order for that to work, you should be careful to place the first screw on the first item of the pattern. So I said I want to put in the screw coming in from the sink side, from the bottom side. So even in the assembly mode, you can actually open the features of the part. So just click on the first hole in the pattern to see what was the original member of the pattern. It's this one. So this is where I will put my first screw. So I go to assembly, I find the hex screw, and it is now really important that we don't use any references in placing the first screw that would not work on any other hole of the pattern. So the most important first reference would be the axis, of course. You choose the axis of the screw, and you choose the axis of the first hole of the pattern of holes. And now the other constraint that you need is you want to place the bottom of the head of the screw onto that surface. This is the surface. Now you will see that looks kind of funny, but it's not wrong. It's just that these two surfaces are aligned, but the direction of the surface is wrong. So you can flip this constraint, and now it's fine. Now, if you've done everything right to that point, you can just click on the screw, select the screw, and then you have a pattern option. You click that one, you see all these points. That means yes, CREO understands there is a reference pattern. This is why up here on the top left you see reference. Actually, you can roll that down to see there are other options, but reference is in this case because you're referencing an existing pattern. So that is perfect. Great. So we have all these screws. Now, if I want to change something about the screw, it will of course change it with all these screws. Now the nut is still missing, and I said actually before you can place this group two ways. You could create a sub-assembly, a separate assembly, only with the nut and the screw in there. Of course, you would have to put in the exact distance that you need, and then you just pattern this assembly. You can do that. However, here it's better to actually put in the nut separately, and then you can maybe later make a design change, and the whole assembly will change accordingly. Again, you must reference the first item in that pattern. In this case, I will actually reference the screw, the axis of the screw. Oops, sorry, I didn't want to rename that. So let's look at the pattern of screws. Maximize that, we'll see, yeah, this is actually the first screw in the pattern. So now assemble. I already imported the nut. And now I will choose the axis of the screw. If you're not sure, just wait a minute. There will be this little text coming up and it says, yeah, this is the screw. This is the axis of the screw. Click on that. Find the nut. Select the axis and off it goes. And then the same thing again. I will now make the part surface. And in this case, I will choose the lower ring surface. So it's fully constrained. Now, actually, we discussed that before. It's not really fully constrained. In your brain, you should keep record of the constraints. You should be aware that actually you need to define the rotation angle of the nut. But CREO offers this function to allow assumptions here because it recognizes that probably with this part, it's not important how you align it. And it's technically, it's not in the real technical part. You also don't know where, what angle the nut will have after you tighten it. However, maybe for a drawing, for looking good in a drawing, you might prefer to put it into a specific direction, and then you can unselect this and choose one more constraint to align it. So again, what I just want to have is the full pattern. So I just, again, select pattern. It will, if you've done everything right, it will realize there is a reference pattern, and there you go. Now the great thing is, because I placed the nut separately, and I also said before that actually, technically, people would say this screw is a bit too short. Design rule for screws and balls, you should always make sure you make full use of the complete thread, and that is only the case if the screw is actually coming out of the nut a bit, because you have tolerances, right? Some of the screws might be a bit shorter, and then the other parts might in reality be a bit thicker. So what I will do now is, this is new, I didn't show that before, I will now open this plate and make it a little bit thinner. Okay, so I just, you can use the change actually. Although in this case, it's even easier to redefine. So I will make that 2 millimeters thinner if I manage to double click this. Yeah. So instead of 50, it's now 48, which by the way is always a good idea because the raw material you would buy would be 50 already. And you want to make it nice and shiny, so you want to cut something off on both sides. So this is why 48 would be a better dimension anyway. So I've saved that, and I can save it again, by the way, just to remind you that maybe you want to go ahead and do manage file, delete old versions to clean up your drive. So if I now go back into the assembly, here, you see that the plate is a bit thinner now, and all the nuts seem not to be fastened. But of course, that will be fine after I regenerate the assembly. So I hit regenerate, now all the nuts go down, now it's perfect. Now every designer would be happy with that because I can be pretty sure that I make full use of the thread length. So that was, ladies and gentlemen, I'm done. Are you done? Did you put your screws and nuts in? Great. This was basically the demonstration for today. So I hope you now have some good insight, not only how to manage an assembly, but how to model an assembly in a clever way with good modeling quality, right? So basically we had two major items. Item number one is if appropriate, use a skeleton model. That is not always necessary, by the way, right? But typically if you have more complex assemblies, it can be useful. So the skeleton basically is like a sketch. It's something you would do on a piece of paper to plan where everything is. And if you do that well, then your assembly is super stable. Sometimes if you have an assembly where you reference real part on part surfaces and you change some part, then your assembly will explode because all the references are missing. And with the skeleton model, that is one way to avoid that. And in the real industries, for example, if I wanted to do a CAD model of a train, something with thousands of parts and sub-assemblies, I would definitely have some sort of skeleton model to do that. The second thing we talked about was using patterns where applicable. And in mechanical engineering, patterns happen quite a lot. And again, there my message was model wisely. Think about the complete modeling steps right to the end before you start really making CAD models. So you can identify potential for clever modeling. For example, as I did it before, make the second part as a copy of the first one. So already I don't have to model the pattern 2 times. And then especially placing fasteners on this pattern. Now the assignment for today is making use of the exact same techniques. So you have a an inline skater that I want you to design. Now, so the actual assignment is actually to design the missing part here. What you see here is that the 4 wheels seem to be flying, and you have to design the missing part. And if you start with the assembly, it is actually easy to design the missing part, right? So what I want you to do is to make a skeleton part first, and place the 4 rollers and the shoe in the skeleton part, or in the assembly rather, right? So you, the skeleton part would contain a pattern of these axes, right? And maybe even a datum plane to place the shoe on. So this is what I'm giving you. So now I'll change my working directory. I can do that. Manage session. Select working directory. I go into this one now and just checking out what we have. So we have this little assembly here. That is not a lot, but you don't need any more at the moment, right? And then what I also have is I have the shoe. Okay. Also, what I haven't used that is a circlip. This little lovely part you can put on these shafts here. Okay, you can adapt that later on if you want to. So again, what I want you to do is I want you to make a new design of the missing part here. So some sort of housing, and of course the housing has to have some feature that you can connect the boot with it. So I suggest you put screws in from the bottom, screw them into the boot, maybe 4 screws. And the part also needs to have the holes so you can put the little shafts in there for the rollers, right? And the best strategy to model that is to make the assembly first, put all the parts in the assembly, then you can move the parts around until you're happy with the layout. And then you can you can already measure in the assembly, you can check how long the part needs to be and so on, and then you can just start modeling it. You can put the part that you want to design into the assembly very early, even if it's just 1 block of material, and then every step you take, you can check in the assembly already. So what you need to do first is make a skeleton model, use a pattern of axes, so you can put the wheel pattern in there. I think you can do that already, but I will show you, because I'm in a good mood, I will try to do that anyway. So I will make a new file. I will call that a skeleton, not dot, skeleton inline. I do that because there's one way to draw a point there's one way of creating the datum pattern that you don't know yet. So I will actually make a sketch of a point, and then I can create a pattern of this point. Okay, so watch me now. This is something I want to show you. Sketch is easy. I sketch here. Right is on the right. That looks good. Because there are 2 points. I've seen on your computers you have the same menu that I know. So look in your sketch menu. basically you have two different axes, two different points in your sketch menu. Maybe you have noticed that already. But basically on the left side of the menu, you will have center line and point and coordinate system. And on the right and around here, you will also have that center line and point and coordinate system. Now on the ones on the right hand side, you can use if you only need that inside the sketch. But I want to have a point outside of the sketch, so I have to use it on the left hand side. Problem is, in my menu, I'm not so sure. So anyway, I'll try it anyway. Now what is important is that you're using dimensions to create that point. And because later I want to use these dimensions as patterns, right? So I'll just say, how many wheels do I have? 4. So I have 3 distances, maybe 100. So that would be 150. 150 here and 50 here, maybe. So with these 50, I'm defining the distance to the shoe. Now I'm activating. Ooh, I'm lucky. So now I'm outside of the sketch. I activated visibility of point. I can see the point, so I'm lucky already. So what I just do is, oh no, I don't want to double click it. I want to click it and then create a pattern. And I will use this one. And I will say minus 100 because the pattern should go back, should go in the other way. And I don't want 2 points, I want 4 points. So by the way, the distance 100, I don't know, right? That is your design. You can change the distance. So I have 4 points now. To place my wheel, I should use this. To place my wheel, I need an axis, and of course I will take the first point and this datum normal, and again I can now just right hand click the axis and say pattern, and automatically everything is a pattern. And then the same thing, I will just do an assembly. I will call it inline snap. I will place the skeleton inline, which I haven't saved, so it is only in session. We'll place that. I'm lazy, I will use default. And now same thing, I can just put in my little wheel. I have to move that a bit, hang on. Ah, interesting. We have, not dimension, we have a unit system problem here. Okay, so that is interesting though, because then we can change that. Okay, maybe I did that just to tease you. Anyhow, so I will place that. I want to have the center plane. Interesting. I don't quite get it. In that center plane, I will make the first axis of the pattern. I hope this is this one. Coincide with this one. Now I can pattern that already, but it will look a bit wrong. 4 points here. Very big wheels, right? So it seems the unit system in these parts is wrong. No problem, just change it. Can I please open this part? Cannot. Let's see. Unit system, maybe you remember you find under manage file. No, sorry, prepare model property. Oh yeah, it has this weird unit system. Why? That's not my style. Set, and what I want to do is interpret. So it will be a lot smaller now. And close everything, can save the file. Let's go into the assembly. Woo! The V is tiny already. Great. Now open this. Open this guy, do the same thing. File, prepare, model properties, unit system, interpret.
close, close, save, close the window. Yay. Oh, where is it? There it is. So I think probably the boot will be wrong too. But let's try to get the boot in first. No, funnily enough, the boot is correct. Weird, what happened there? So that would be the service of the boot. And then one more. Coincidence. Center plane. And then, of course, where is the boot now? This is where you have to start planning, right? So obviously I put in this and it's kind of centered, looks pretty good now. So now I see, well, I have to move the wheels down more, right? And maybe the distance is too small. I have to spread the distance. So this is already your design. You're designing, but you're not working on the part model, but by changing the skeleton model and thereby changing where's the boot, where the wheels, that's the most important part of the design. You are planning the main dimensions. And then when you're finished with that, you start modeling the new part. And you will put the new part into the assembly and just put in the features that you need. And this is your assignment.